Hello everyone. Now in this session we'll have to study code tree, trellis and state diagram. This is the most important part of convolutional encoder. So the structural property of convolutional code can be portrayed in graphical form by using any one of the three equivalent diagram: code tree, trellis or state diagram. So basically this is a graphical approach which is useful to portray the structural property of convolutional code. So we one by one we will see all of this. Now for that purpose we can consider one example and we will try to solve this example, and we will see the how to draw the code trees, trellis and state diagram. So let us have a look on the numerical. A code rate of 1 by 3 convolutional encoder has generating vector has G1 111, G2 100, G3 110. First question is sketch encoder, draw code tree, trellis and state diagram, and the next question is find out output code word for input 101. Now the first question is to sketch the encoder. Now first of all, from the given code rate we'll have to decide what is the value of k and what is the value of n. We know that a code rate is defined as the ratio of k by n. We have earlier defined the code rate as k by n. So if it is 1 by 3, the value of k is 1 and the value of n is 3. What does it mean? The convolutional encoder is accepting or operating 1 bit at a time, and for that corresponding 1 bit it is producing 3 output bits. Now let us try to draw the code tree here. Now from the given impulse responses G1, G2 and G3, since here how many responses are mentioned? 3. It means how many XOR gates are available in the or that we need to draw in the convolutional encoder? 3. G1, G2, G3, since these are 3 responses, it means 3 XOR gate, and in every responses how many bits are given? 333. It means how many shift registers are available? Total 3, as they shows the connections from the shift register. So let us draw the diagram. So how many shift registers we require to draw the design? 3 shift register. Why? Because in this G1, G2, G3 only 3 bits are given. So 3 shift register, and since these 3 values means 3 XOR gate. So this is what the diagram of convolutional encoder M0, M1, M2 inputs we can apply to the first shift register and 3 XOR gate. Now G1, since the value of G1 is 111, that means the connection from the first shift register, second shift register and third shift register to the first XOR gate. That's why from all of this 3 shift register the connections are coming to the first XOR gate. Now to the second XOR gate, the connection is only from the first shift register and no connection is from the second and third. Why? Because the values are second and third value is 0. So first shift register connection is there, and to the third XOR gate the connection is from first shift register and second shift register and no connection from the third shift register. So first and second connection is to the third XOR gate. This is what the design. Every XOR gate will providing us the output x1, x2, x3. This is what the switch we are using. The switch is connecting to the terminal number 1 first, second next, and at last 3. And this is how we are getting the output code. So this is what the sketch and sketch of the convolutional encoder. Now the most important thing here is to draw the code tree, trellis and state diagram. Now to draw the code tree we'll have to follow some of the rules. Now what are the rules that we need to follow? Number 1, rule number 1. When we are moving upward, when we move in upward direction, then we need to put 0 over transition, and if we are moving in downward direction, then we need to put 1 over transition. So this is very important rule. Number one, when we move in the upward direction, then we can put 0 over transmission. It means it is because of input 0. And if we move in the downward direction, then we need to put 1 over the transition. It means it is because of input 1. So let me draw here a code tree. So I can start from here. So here in the stage 1, we are getting only one node, and let's say that node is node A. Now when we are moving in upward direction, put 0, and when we are moving in downward direction, it is because of input 1. So every node will gives us 2 more node. So in stage 1, since node A is as an input node, in the output it is giving us 2 more node. Let me write their name, node A and node B. So this is stage 1. Now let me go for stage number 2. Once again, we can move either in the upward direction or in the downward direction. So if I am moving in upward direction, it is because of input 0, and if I am moving in downward direction, it is because of input 1. So every node is giving us 2 more node. Now similarly, for input from node B, we can move either in upward direction, so 0 is there, or we can move in downward direction, so 1 is there. So in stage 2, we are getting how many input nodes? We are having 2 input nodes, and how many output nodes we are having? 4. Let me write their name, A, B, C and D. So we are having total 4 nodes as an output of the stage 2. Now if we can continue this. It depends upon the number of input for which we will have to draw the code tree. Now how many number of inputs for which we need to draw the code tree here? So the input is given here 101. It means for 3 input bits we will have to draw the code tree. So since 3 input bit, it means we'll have to look at the 3 stages. So one more stage we need to draw here. If only 2 bits given, so we can restrict ourselves up to 2 stage. If 4 bits given, we will have to draw up to 4 stages. So let me draw one more stage. So if I am moving in upward direction, it is because of 0 input, and if I am moving in downward direction, it is because of 1 input. Similarly, from B, I can move in 2 direction, 0 and 1. Now from C also, it is possible for us in the 2 direction. In upward direction 0, and in downward direction it is because of input 1. And from D, 2 more connections, 0 and 1. So if we looking at stage 3, total number of input nodes are 4 and total number of output nodes are 8. Let me write their name, A, B, C, D. A, B, C, D. Please don't write another node name. So total number of nodes are only 4 and their names are A, B, C, D, A, B, C, D. Now if you are moving in the 4th stage, then this 8 node will giving you the 16 nodes. So how can you write there? A, B, C, D, A, B, C, D, A, B, C, D, A, B, C, D. Likewise, you can draw the 4th stage. So this is all about the code tree. One thing is left here, which is we need to write the output of the code word on every horizontal line. So when we are moving from node A to A, it is because of input 0. So what will be the output that we are getting here? Or when we are moving from node A to B, it is because of input 1. So we need to write here the output in the bracket. So what is that output that we need to write here? So if we look at this particular convolutional encoder, now here I am going to prepare one table, content of shift register and output code word C. So I have already prepared here one table. If you see, this is what the table. content of shift register and output. What are the content of shift register? M0, M1, M2, and outputs are X1, X2, X3. Now let us write first of all the values of X1, X2, X3. So X1 is M0 plus M1 plus M2, X2 is only M0, and X3 is M0 plus M2. So we have written already here X3 is M0 plus M1. Now what we are doing, yes, have a look. This is what our code tree is. This is our code tree is. Now we'll have to write the output here. So what we can do, we can track the inputs from right hand side to the left hand side, means from final stage to the initial stage. So if we like, if you wanted to write it for stage 1, it means we just have this stage. It means only node A in the input and A, B in the output. So we can track it from left hand side. Since this is stage 1, it means it is having only two inputs, either 0 or 1. So that's why M0 is having either 0 or 1, and M1 and M2 don't have any inputs, so they are 0. So for these three inputs I can calculate X1, X2, X3. So all are 0, it means all 0 output, and if it is 1 0 0, X1, X2, X3 is 1 1 1. With the help of this equation I have calculated this. Now if I am moving in stage 2, now I may have 4 combinations, 0 0 0 1 1 0 1 0. So I can write them from final stage to initial stage. So how can I write them? So I just need to track this input. So if we see this, these are the output nodes of stage 2, right? So this is input 0 0 0, next is 1 0 0 1 and 1 1. So 0 is the main root, and because of this main root we got the two subroots here. So that's why 0 0 1 0, and because of this main root 1 we have two more subroots 0 1. So 0 1 1 1. While writing we need to follow from final stage to the initial state. So what I have written here, 0 0 1 0 1 0 0 1 1 1 1 1. So during stage 2 the content of the third shift register is still 0. So because of this bits we are getting output, which I have written here with the help of same equation. Now if we are looking in the third stage, so third stage means in the third stage the total number of output nodes are 8, and let us track now the inputs. So how we can track the inputs from final stage to the initial stage? So this is 0, then we are here, then this is 0 and then 0. So all 0, then 1 0 0. So I have written all 0 1 0 0, then we are here. So 0 1 0, then 1 1 0. So 0 1 0 1 1 0. Then next here 0 0 1 and then 1 0 1. So 0 0 1 1 0 1. Next will be 0 1 1 and 1 1 1. 0 1 1 1 1 1. So that I have written here 0 1 1 1 1 1. So for this I have written their corresponding outputs also. Now we'll have to write this output on this tree diagram. I have drawn here this tree diagram here. So if you see stage 1, stage 2, stage 3. Now when we are moving from node A to A in the stage 1, it is because of this input 0, and what will be the output? It is 0 0 0. So that's why I have written 0 0 0. And when we are moving from in the downward direction, it is because of input 1. So for that I have written the output 1 1 1. So 1 1 1. Now in stage 2, what are the outputs? So outputs are 0 0 0 1 1 1 1 0 1 0 1 0. So 0 0 0 1 1 1 1 0 1 0 1 0 0 1 0. So we just need to write this as it is in this particular. So the next 8 values we can write here 0 0 0, and please try to write these values in the bracket over the horizontal line. So this is what the rule, you need to write these values over the horizontal line. So this is all about code tree. Now let us move ahead and let's see how to draw the code trellis. So while drawing the code trellis, we will have to look at one simple rule, and the rule is like, if the input is 0, then we can draw a solid line, and if the input is 1, then we can draw a dotted line. Now from the code tree, if we see this code tree, one thing is for sure, if we are at input A, it will only gives us two output node, that is A to AB. So whenever the initial stage is A, the final stage outputs are always having two nodes, A and B only. So from A, we will always get two ways, A to A and A to B. When input is B, we are always having two ways, B to C and B to D. If you see any input bit, so from B there are only two ways, B to C, B to D, B to C, B to D. Now similarly from C there are only two ways, C to A and C to B, and from D there are only two ways, D to C and D to D. So you need to keep this in your mind. If the initial state is A, it means the next state will be AB. If initial state is B, next state will be C and D. If the initial state is C, next state will be A and B. If the initial state is D, next state will be C and D. So while drawing the code trellis, this is very important. If initial state is this will be the next state. These are the next state. Now let us draw the code trellis. So which rule I told you? So rule is very simple. If input is 0, draw a solid line, and if input is 1, then draw a dotted line. Very simple rule. Now let us first of all write the initial state, that is present state. So how many initial states are possible? A, B, C and D states. Now in the next state, we know that the input might be coming to the convolutional encoder is either 0 or 1. So if the input is 0, then we can draw a solid line. So from input A, we can go either A to A or A to B. Now how can we decide if it is A to A? It is because of 0 input. So once again we are getting this idea from the code tree. If we see this code tree, so when we are moving from node A to A, it is only because of this 0 input. You can see A to A, it is only because of 0 input, upward direction. And A to B, it is in the downward direction, means it is because of input 1. So same thing we can use here in the code trellis. If we are moving from A to A, so it means it is because of 0 input, and since 0 input, it means we are going to draw a solid line. And at the same time, we can also write the output, corresponding output, which we have written here on the horizontal line, that is 0, 0, 0. So 0, 0, 0, and if we are moving from A to B, it is because of input 1, so dotted line, and therefore we can write the output 1, 1, 1. Similarly, from B, there are two final state, next states possible, B to C and B to D. B to C, it means because of 0 input, so solid line, and B to D, it means because of 1 input, so dotted line. If we see the tree diagram, so where is B? Here. So B to C upward means 0 input, so solid line, and B to D downward direction because of input 1. 1 means dotted line. So B to C solid line, B to D dotted line, and their corresponding outputs we can also write. B to C means 1, 0, 1, and B to D means 0, 1, 0. So 1, 0, 1, 0, 1, 0. So the same thing we can follow for the C and D also. So from C, two states are possible, C to A and C to B. C to A because of 0 input, so solid line. C to B is because of 1 input, so the dotted line, and their corresponding outputs. Similarly, D to C and D to D. D to C is because of 0 input, so solid line, and D to D is because of 1 input, so dotted line. And don't forget to write their code word also. So D to C, if you see the D to C, it is because of 0 input, so solid line, and the output is 0, 0, 1. So don't forget to write this output 0, 0, 1. And D to D, it is because of 1 input, and the output is 1, 1, 0. So 1, 1, 0. This is what the code trail is, but this is for only single stage. Now how many stage we will have to draw here? So it depends upon how many input bits for which we will have to draw the code trellis. Now how many input bits are given to us? 1, 0, 1 means 3 bits. So how many stages we need to draw here? 3 stages. So the same thing we will have to draw for how many times? three times. 1 2 3. This is just, we need to copy and paste it here, and once again same pattern will be repeated. So this is what I have drawn here, this particular code trees. You just need to draw this two more times, here and here. Okay, so if you see A B C D, and these are the possible ways I have drawn here, A B C D, and the same pattern I have redraw here, A B C D. So A to A to B, B to C, B to D, dotted line this way, and similarly their output. So this is what the way to draw the trellis diagram. Now to track the output with the help of trellis, so which input is given to us? 1 0 1. 1 means what? A dotted line. So dotted line, now we can start from here. A dotted line means what? One input means dotted line, so we can move in this direction. So there we will get the output 1 1 1. So for 1 we are getting the output 1 1 1, we have written here. Now we are coming from stage A to now stage B here. Now from here the next input is 0. 0 means what? We'll have to look at the solid line, so we can go from B to C. So we are now here, and which output we are getting here? 1 0 1. So 1 0 1 I have written here output. Now from here the next input is 1, so we can either move in two directions from C to A or C to B. C to A means solid line and C to B means dotted line. Dotted line, since 1 we wanted, so that's why dotted line. So C to B, and which output we can write here? 0 1 1. So this line is having the output 0 1 1. So this is what the way to get the output for the corresponding input. Remember, these things you need to redraw as it is. You can connect this 3 times, so you will get it for 3 inputs. If there are 4 inputs, you just copy and paste it for 4 times, and the connectivity you should maintain. So this is all about code trellis, and state diagram is very simpler one. State diagram in which you need to first of all write A B C D. This is not a proper, we can't say like any proper way is there in the state diagram. You can write the way you wanted, you can draw the way you wanted state diagram. So this is what the way I have drawn here. So for states, 4 nodes I have drawn this way, A B C and D, and we know from if initial node is A, so there are 2 ways to go from A to A itself. So it is because of input 0, and what will be the output? 0 0 0, and A to B is also possible. So output, when we are moving from A to B, which output we are getting? 1 1 1. Now if we are looking at node B, so 2 ways to go from B to C and B to D. So when we are moving from B to C, the output is 1 0 1, and when we are moving from B to D, the output is 0 1 0. Similarly from C there are 2 ways to go, C to A. So when we are moving from C to A, we are having this output 1 0 0, and C to B. So we are having 0 1 1 output, and from D 2 ways to go, D to C and D to D itself. So when we are moving from D to C, this is what the output 0 0 1, and when we are moving from D to D itself, like here D to D itself, so what is the output? 1 1 0. So we can write here output 1 1 0. So this is what the state diagram. So this is all about code tree, trellis and state diagram. Thank you.